Hello, everybody. How y'all doing? Hopefully, you guys had a wonderful weekend. So we have Jewel in the house. We have Momo in the house. We have Lonnie in the house. We have Zoe. Hey, Zoe. Damara, how are you?
Hey, Miss
How's
Tate.
everybody? How you doing, Malone?
I'm doing good.
Good. Good. All right, we have Grace that joined us. Hey, Grace. It's good to see people on here. Okay. All right, we're going to give about another minute or so before we get started, Malone and
Okay.
friends. Clutch, how are you, Clutch?
I think that's Zion.
Yep, Zion Peters, right?
Mm-hmm.
Mm-hmm. Good to see you. All right. Okay, so we have our warm-up up here. Let's get started. Hey, Walker. Let's get started. It says, can you feel? You want to read that question for us, please, Milani?
Mm-hmm.
Yeah.
Can you explain why you feel warm when you are standing near a campfire or a fireplace?
Okay. You want to share your thoughts on that?
I think you feel warm because of how hot the temperature is of like the fire,
And what does that mean?
like of how much like how like the heat, like how like the heat is coming to you.
Okay.
The temperature, yeah, the temperature.
Okay, so you said the heat is coming to you. So you're saying that when it comes to a fireplace, it could be a fireplace or a campfire.
Mm-hmm.
You're saying that that heat stays in this section here? I mean, it doesn't stay here. It actually moves out. Is that what you're saying?
I mean, it can move out, but I'm saying like it could be like the temperature, but it can move out because a fire can spread like quick. So like it can move. It's a possibility that it can move, but I think it would maybe stay in that place if the fire is like boiling from that place, but it can spread, but it can still
Okay,
spread.
so let's clear this up. You're saying that the fire could spread. Are you saying that the fire can actually spread, or you can just feel the heat from another area?
I'm saying that you could feel the heat from another area because of how hot the fire is, like,
Okay,
and it
all
makes your
right.
body
Okay, well, we're going to
very hot.
see if you we're going to see if you still have that same thought process by the time class ends. Let's take a look at our classmates. Let's read what they say. Grace says it's because the heat is from the fire. Jules says because of the energy or the heat. Momo says the fire is releasing heat. Also, the
Heat.
fire is releasing heat and your hand absorbs the heat. Okay. You all have come up with some great thought-provoking answers. Is there anything else y'all would like to add before we move on?
Mm-mm.
All right, so by the end of today's class, you all will get a total understanding or be able to explain in more detail about how we feel warmth when we're standing near a campfire, or a fireplace. Okay. All right, so again, by the end of today's class, you're going to be able to fully understand more how we feel warmth in these areas. Okay. So
Uh-huh.
here are some key terms. I need you to make sure you write those items down, those key terms down, because as we go through class today, you will have to define them. Okay.
Write them down like on a
Milani?
sheet of paper.
All right, make sure you all get a sheet of paper out and something to write with.
All right.
Get a sheet of paper out and something to write with. Once you've got those items out, I need you to give me a thumbs up. Once you got those items out, I need you to give me a thumbs up. Stewart, thank you for joining us. Miss Israel, thank you for joining us.
Miss Green is in the house.
Miss Green is in the house. All right. I am still waiting for, okay, Momo has a thumbs up. Thank you. Thank you. Thank you. Okay, so at this point, you should have written down heat transfer, leave some space, thermal energy, conduction, radiation, and convection. Please be sure that you leave some space. After you've written down those 5 key terms, I want you to be sure that you give me a thumbs up. Capiche?
Mm-hmm. Thermal energy. What does that third one say?
That third one says conduction. CONDUCTION.
All right.
Hello, Taimani. All right, I need you to now send in or type in a heart to let me know you are finished copying down all 5 of those terminologies.
You said send a heart.
Very good, Momo.
Whew.
All right. All right. For those who are just joining in, we are copying down these 5 terms and then we're going to move on. All right. All right. Milani, let me make this clear to you guys. So,
Okay.
can everybody see this right here? So originally, I told you guys that we're going to be working with these 2 on this particular sheet in our mission line or our actual packet for the week. That is absolutely true. However, I'm not going to do it page by page, okay? What I'm doing is I'm doing my whole entire lesson. I'm doing my entire lesson, and you should be able to answer these questions on your own when the lesson is over. If you understand that, please give me a thumbs up.
Okay.
If you understand that, give me a thumbs up. Thank you. Thank you. Okay. Now, thank you. Let's go back to our lesson. All right. All right, so Milani, read the warm-up, made the objective, please.
Okay. By the end of the lesson, students will be able to. I can't see the. Oh. Okay. Never mind. What's that word in the I can't see that word.
Evaluate.
Evaluate heat transfer. Yeah, evaluate heat transfer, via interactive activity and discussions to differentiate between conduction, radiation, and convection.
Convection. Okay. So
Convection.
by the end of the lesson, we should be able to understand and know all about heat transfer. You see that? Okay. And we should be able to discuss and differentiate between these three terms: conduction, radiation, and convection. Okay? All right, so we did our warm-up objective. We're about to go on to our lesson. All right, first things first. You want to read that, Milan?
Okay, yeah. Heat is a measure of the flow of thermal energy from one object or substance to another, warmer to cooler.
All right, so let me give you an example of what we mean by that. In order for that flow of thermal energy to occur, it has to go from the from the warmer object to the cooler object. So for an example,
Right.
I have,
Bro, why's my gossip in my stove, bro? The heck?
what do I have in front of me? What do I have? What is this? Type in what
Is
this
that a
is.
kiss?
Type this
A
in.
Hershey? Is that a Hershey kiss?
Yes, I have a
Okay.
Hershey Kiss in my hand.
Okay.
Okay. All right. Now, what could happen? You're going to type this in. What could happen? Thank you. Hershey Kisses. I'm seeing answers. Thank you. What could happen or what will happen once I hold this Hershey Kiss in my hand for some time? If I was to hold it in my hand like this,
It
what
will
will
get
happen?
warm.
Allow them to type something in. Milani says it is going to get warm. Tariq says it's going to melt. Jewel says it will melt. Okay, so a lot of people are saying that this will actually melt. Why?
Because of the heat from your hand. Like,
Thank you. The heat from my hand, because my body temperature, my temperature is higher than the temperature that's within this chocolate. Okay?
yeah.
And once temperature or heat hits chocolate, is going to do what? Grace said it will melt because the heat from your hand transfer. Absolutely. Thank you, Gracie. That's the answer that I'm definitely looking for. The heat will transfer from your body or your hand to the actual Hershey Kiss. Okay? So, everybody understand that concept? Reek
Yes.
said your body is most likely hot and warm, correct? Okay. All right, let's move on. All right. Thermal energy. Who would like to read this? Milani, read this, please. Milani, you ready? Okay, I'll read it. Thermal energy
Yeah, I'm ready.
typically flows
Okay.
from a warmer material to a cooler material. So in essence, my thermal energy was transferred from my hand to the Hershey Kiss, just like you all said. Okay? Oops. Generally, when thermal energy is transferred to the material, the motion of the particles speeds up and causes the temperature to increase. Okay? When we talk about particles, y'all remember what that means? Milana, you remember what particles are when it comes to the states of matter?
Like stuff that like floats or like things that's like on the ground. I don't remember.
You don't remember? Okay, I'm getting ready to bring back to your remembrance. Anybody know what when we talk about particles for the states of matter? This statement is saying the motion of the particles speeds up and the temperature increases. So they're saying the more temperature or the higher the temperature, the faster the particles actually move. We're not talking about small cells. I'm going to review. Atoms and molecules. Okay, Jewel. What do you mean by atoms and molecules? Imani saying something that bond.
Okay.
All right, Grace, you remember? What do you remember, Grace? We'll get to that. We'll get to that. All right. For now, I need you to understand that there are 3 types of heat transfer. Milani, can you see this?
Yes, I can see it.
Can you read the first one?
The first one is conduction.
Mm-hmm. Young Boy Reed says it's liquids and gases and solids. Correct, Mr. Reed. Correct. The colder the temperature, the slower the atoms go. Correct. So we're getting ready to show you all how the particles look if it's in a solid, a liquid, and a gas. Thank you so much. Thank you, thank you, thank you. All right. So as Milani just said, the first one is conduction, convection, and radiation. The question I have for you all is, can we have 3 methods of heat transfer all at once? Want y'all make a prediction on here. Either type yes or no.
Where did my pencil just go?
The question is, can we have 3 methods of heat transfer all at once? I want you to either type yes or no.
I don't think we could.
Make a prediction.
3 methods of heat transfer. Yeah, I think we could. I think so.
You think so? Okay, someone saying maybe, someone said we think we could. I believe so. Yeah, I think yes. Okay. Yes. All right. I need everybody. Okay. So the answer is absolutely yes. Absolutely yes. By the time we leave here today, you're going to see how that is possible. Very good. Very, very good. The answer is yes. As we were just talking about the particles, here we have solids, liquids, and gases. Okay. The particles within these look differently, they are arranged differently, and it's all according to how much energy they actually have. Okay. Take a look at our solids right here. Please explain to me how the particles actually look, Milana.
Okay, so for the solid, the particles are like all bunched together.
Okay.
Like together. And for liquid, the particles are like kind of more space like.
So back up right quick. You said for the solids they are packed together. Why are they so packed together? What are they forming? Why are the particles so packed together? They have to form a what?
Are they forming like a new substance? Or new
Not necessarily a new substance, but they form a particular shape. Okay? So can y'all see this? Y'all see this?
Yeah.
So what shape is this? What shape is
square.
This? It's a square. Okay. Is this a solid, a liquid, or a gas?
A solid.
It's a solid. Now, are the particles close together or far apart?
Close together.
All right. The reason why they are so close together is because they actually have to form that shape. You understand?
Okay.
Mm-hmm. Okay. Otherwise, if they're not close together, if I was to light this on fire, this will no longer be a square. Okay? Why?
Right.
Why?
Because the molecules wouldn't be in that form anymore.
Okay, so the particles will start to do what? Will they?
They will start to spread.
Thank you. Because what am I adding to it?
Heat.
Thank you. You can actually say heat energy.
Heat energy.
All right. All right, so we're saying it's a solid. Yup, it's close together. It's packed. It has a definite shape and volume. Absolutely. They bond together. So the temperature is cold. I like how you said that, Gracie. Why do I call you Gracie? Grace. Okay, it's
He
cold
called her
inside.
Grace.
I know, I'm sorry. All right, so
Oh my god.
when it comes to liquids, are they as close together? Milani, are they as close together?
No. No, they're not.
They're not close together. Why?
The liquids, I mean the particles, the molecules, they're spread out more than the solid had a shape.
So the solid
Solid
has
had,
a shape. What
but
about liquids?
liquid
Liquids?
that
Do liquids
that
have shapes?
no.
What do they have? What do they actually do? If they don't have actual shape, because right now I have a bottle of water. This is a liquid, correct?
Yeah.
All right. Are the particles moving?
Yep.
Absolutely moving. Now,
Mhm.
we already said that liquid does not have a shape, but it takes the shape of the what?
The bottle.
The bottle or the container that it's in.
Yeah.
Okay. All right. Yes, it has a definite volume. I do, and not definite. Right. Definite volume, no shape. It depends on the container it's in. Absolutely. Very good. All right. When it comes to gas,
Okay, now the particles are very spaced out.
okay. Why?
Um, I think this is because um they don't have a shape. I can tell you that. It's not like a shape formula, but they're far apart and don't have a definite volume or shape. Yeah, it doesn't have a volume or shape,
Okay, you're right.
honestly.
So listen. Out of these three states of matter, okay, which one has the most energy? What particles move the fastest? Let me say that. Is it solids, liquids, or gases? Which particles move the fastest?
I think it would be yeah. Young boy Reek said gas.
Gas, absolutely gas. All right, let me give you another example. Milani and friends, if I gave you all an ice cube,
Yes.
okay? If I gave you an ice cube, what state of matter is that? Type it in, please.
Okay.
If I gave you an ice cube, what state
Everybody
of
said
matter
gas.
would this be? A solid, a liquid, or a gas?
It would be a liquid.
If I gave you an ice cube,
Oh, it would be a solid.
thank you. It would definitely be a solid. Okay? All right? Those particles are not moving. It has a shape of a square or the ice cube or whatever shape that your ice comes in. It's definitely a solid. However, if we were to sit it out on the table, it becomes what, Milana?
A liquid.
Why?
Because of the heat, it would start to melt. The
Thank you.
ice would start to melt
Heat
in the yep,
because of the heat.
heat
Heat
energy.
was basically added to it, or they absorbed heat from the surroundings, and now it has become a liquid.
Yep.
Very good. It started to melt. Very good. On the contrary, how can I make that cup of water or that ice that I once had, how can I make that become a gas?
I don't. Okay. Let me think.
What do I
Um,
have to do to that? Young boy Reed, he says it eventually become a gas. Please tell me how it can become a gas. What can I do to make it become a gas? Somebody said boil. Absolutely. You can
boil it.
boil it. Yes. Have you ever boiled your hot dogs or your mac and cheese and you've seen the
Yeah,
actual,
I've cooked some. Yeah, I've
okay?
boiled some hot dogs before.
Absolutely. Boiling it, very good. So I just wanted to give you all a quick review of the particles of a solid, a liquid, and a gas. This is going to
Mhm.
be very important with the rest of our lesson. All right. Can I move
All
on?
right.
Give me a thumbs up. All right. All right. So when it comes to conduction, Conduction is the transfer of heat through matter by direct contact of particles. Okay. Imagine it was very cold outside, and as you walked to school, as soon as you came inside, I handed you all a mug of hot chocolate. What happens to your cold hands?
They warm up. They warm up.
So, if I was to give you a mug with some hot chocolate in it,
Mm-hmm.
as Milani said, they warm up. Why, Milani? What actually happens?
The heat from the mug, or like the temperature from the mug, like warms your hands, like warms your hands.
So it transferred to the heat transfers from the mug
Mug to your hand.
to my hand. Okay.
Mm-hmm.
And because my hand is directly touching this, okay, that is called conduction. Remember, it is direct contact. Okay. Everybody have that? Remember, it says the heat from the cup transfers to your hand. Absolutely. Very, very, very good. You all should be writing this down as we are defining these terms.
Conduction, direct transfers.
Direct transfer of heat. Make sure you're writing that down. I need you all to also understand that this happens frequently in solids because in solids the particles are packed closely together. Okay? So conduction happens most frequently in solids. Remember, this is a solid.
Conduction.
Direct contact. Do we have any questions thus far? Do we have any questions thus far? If we have any questions, please type them in below, okay? Otherwise, give me a thumbs up if you are ready to move on. Milani, you ready? All right. Let's move on with conduction.
Mm-hmm.
Can you all think of more examples? Can you think of more examples? Can you see that, Milani?
No, it's like the front is like blurry.
All right, let's move on. What about this? All
Yeah, I
right,
can
you are
see that.
visiting your grandpa. Can you see it?
Yeah, I can see it.
Okay. You are visiting your grandparents and find an old lava lamp. You plug it in. After a few moments, globs of thick colored liquid begin to rise from the base. When each glob gets to the top, it falls back down. What do you think is happening? When each glob falls to the bottom, what do you think is happening? So what you probably can see, you see the globs right here? Milani, can you see the globs? So for these globs right here, they'll go up and down based on what? Do y'all know? All right, so for those who don't know, the lava lamp is basically a glass cone filled with liquid
Mm-hmm.
See how we have this glass part here, this cone up here? All right. And this part is actually filled with liquid
Mm-hmm.
and a bright colored waxy substance. Okay. So that's why it looks pretty horrible right here, but I want to show you all the other picture. It says once it hits the ground, the heat makes it go up. Absolutely. So it's cyclical. Okay. When you turn the lamp on, the heat from the bulb melts the waxy substance and it moves it around. Okay. So it basically moves all of this stuff around here. The lamp clumps, so the rising and the falling due to convection. So this whole process is convection. All right. So convection is one way that solids and gases differ. From solids, it is that they can actually flow. What does flow mean? This makes them fluids. So when it comes to heat transfer and convection, convection only takes place in liquids and gases. Okay? At this point, Milani, what should you be writing down for your definition for convection?
Liquid. Oh, heat transfer. Heat transfer in the liquid or gas by flowing movement of heated particles.
Okay, heated particles. So it says, so the heat gets evaporated and then the coldness drops back down. Well, sort of, yes. You're getting ready to get a better picture of how it actually flows. It's like cyclical, but you're right. The cold portion drops down and the heated portion goes up. Okay, very good explanation or observation. Okay, so in convection, the particles actually rotate and move from one place to another. Okay, the warm fluids rise up here. Okay, see this red part right here?
Mm-hmm.
The warm fluids actually rise and the colder ones will sink. Think
Okay.
about your homes. Think about your homes. If it was really, really hot outside and you had a 3-story house, where where would be the smartest place for you to go to stay cool?
The basement.
Yes, absolutely. So the colder air sinks and the hot air actually rises. So going to the basement would be your best or a great option. Okay.
Yep.
Any questions about that? Yes, the lowest floor, lowest floor. All right. Can we move on? Let's go to radiation. All
Okay.
right. Milani, can you read that, please?
Mm-hmm. You go out to the pool for a nice morning swim. You jump in and the water is freezing. You get in the pool again later that hot and sunny afternoon and the water is several degrees warmer than it was before. What happened? Is this a form of heat transfer?
Okay. So what actually happened?
Um the pool got hotter, warmer. And this was a sign of heat transfer. Cause
So yes, it was a sign of heat transfer. How and why did the pool get warmer?
I think because of the temperature of outside, like the pool warmed up to the temperature. The pool got hotter because the heat from the sun. Yeah,
Very good.
something made the pool hot. Yeah, like the heat from outside made the pool very hot.
Absolutely.
Well, warm.
So the sun, very good, y'all. So the sun actually warmed up the pool and it got actually warmer. Okay, so is this a form of heat transfer? Type in yes or no. The pool is yes, yes. From the heat to the water, yes. So yes, this was a form of heat transfer. All right. So where does all the heat transfer energy come from? Convection
The
and
sun.
conduction. Very good. Conduction and convection require matter, solids, liquids, and gas to actually transfer heat. Okay. However, there's little very matter between us and the sun. When it comes to radiation, radiation is a transfer of energy by electromagnetic waves. Okay. Can you all give me some ideas of where we may have radiation in our homes? More specifically, tell me something that may be involved with electromagnetic waves in your kitchen. I want you to type that in. What examples of electromagnetic waves?
The light and heat, the stove, our oven. The
Are
stove.
you sure? So we're having our stove, we're having our oven,
Mm-hmm.
light, microwave. That's the answer I am looking for. The
Microwave?
microwave. Yes, the microwave carries electromagnetic waves. Okay?
I would think it would probably.
Yes, it
Yeah.
does. Okay. Very, very good. Very good. All right, so this is what I want us to do. You're going to create a column like this on your paper. See these 3 columns?
Mm-hmm.
All right. So you're going to take a sheet of paper. You're going to make 3 columns.
All right, hold on. I gotta get a sheet of paper.
All right.
Those 3 columns, okay.
You're going to make 3 columns on a sheet of paper like the one below here. And as we read each example, you want to classify by placing the number in each correct column. Okay. So we're
Conduction.
going to be reading about 9 examples. And if example number 3 applies to this column, that's what you would write. If example number 2 applies to convection, you will write example 2 right here. And if example number 1 applies to radiation, you'll write it here. Okay. I will say that these answers here are not correct. I'm using these to help guide you. So when you create your 3 columns, leave this
No,
blank for
no,
now. Okay. Make your 3 columns and leave this blank.
no. Who was Golden Nuggets? Zuri?
Okay. Golden Nugget, this is not in the packet, my love.
Is that Zuri?
I forgot who. I think I'm not sure who that is. I forgot. But that's not in the packet. So we already discussed what we're working on. So take out a sheet of paper, make your 3 columns. Once you made your 3 columns, give me a thumbs up. I'm waiting on a thumbs up. Jewel is ready. Milani, you ready?
Yes, I'm ready.
All right. So, first example. Read the first one, Milani.
A pat sitting on a hat burned. I can't see the last part.
Oh, I'm sorry. Burner.
Okay, a pot is sitting on a hot burner.
You all must decide under which column it's going to be in. So write that in your column. Will it be under conduction, convection, or radiation?
Let me check.
Very good. Wherever you think example number 1 should go, that's where you should put it.
Oh, I know.
A pot sitting on a hot burner. All right.
I know.
Example number 2. Example number 2, touching a metal spoon that is sitting in a pot of boiling water.
Whew,
Touching a
okay.
metal spoon that is sitting in a pot of boiling water.
Oh, I know that one.
And number 3, a person placing their cold hands over a warm fire. A person placing their cold hands over a warm fire. All right. All right. So you all should have completed that. Let's move on to the next one. The next set, number 4, picking up a hot cup of coffee.
We just did that.
Using an electric blanket to get warm.
We just did that one. Oh, I know that one. That's example.
And number 6, putting your wet shoes on the floor vent to dry them faster. All right, that's number 4, 5, and 6. Let's go to the next one. Milana, you ready?
Yeah, I'm writing down my last one, but yep, you can go ahead.
All right. Number 7, lying out in the sun to get a tan. Number 8 is macaroni rising and falling in a pot of hot water or boiling water.
Laying out in the sun to get. Oh, that one is okay, I know that one.
And number 9, cold water sinking and warm water rising in the ocean.
Michael.
All right. Give me a thumbs up when you are ready to go over the answers. Give me a thumbs up when you're ready to go over the answers.
Oh, I think I know that one.
All right, Golden Nugget is ready. All right.
All right.
Are you ready?
Yes, I'm ready.
All right. So, take a look here.
Dang, hold on.
So for column number 1, what should we have, Milani, for number 1?
Example 1.
What else?
We should have example 2,
Mm-hmm.
example 4, and example 6.
Yes.
I did not have no example 4.
Please be sure you are checking your answers, okay? So the example 1 should be there, 2, 4, and 6. All right. Take a look at convection.
We should have example 8 and example 9.
What was the clue for convection? What are some terms that made you think it was convection? It should have been falling, rising. Cold water sinking.
Yeah, heat transfer.
Wait a minute. Well, cold water sinking and the warm water rising. Okay? Think about that. That is an actual cycle. The cold air or the cold water is sinking towards the heat. Okay? And the hot water is going or rising because it's already been heated. You understand that? Very good. We got rise and sink, rising, rise. Very good. All right, take a look at radiation. Can you read those 2 answers?
Okay, example 3, example 5, and example 7.
Okay. So using a person laying their cold hands over a warm fire, electric blanket, and laying out to get a tan. Okay. Very good. Are there any questions about those?
Dang, we only got 1 minute.
All right. Yeah, we have 1 minute left. Time is going really, really fast for us today. Okay.
Okay.
All right. All right, let's go over our exit ticket. I want you to screenshot this.
You
Screenshot
want me to
this.
read that?
Yes, you can read it.
Okay. What would happen if a person who is wearing a heavy winter jacket were to place a thermometer inside the jacket?
Thermometer.
Oh yeah, thermometer inside the jacket next to his or her skin. What would happen if we took the same jacket after it had been hanging in a closet and placed a thermometer inside?
Okay. So at this point, you should have screenshotted that. This actual question is in Canvas, as well as your warm-up question is in Canvas for you to answer. Okay.
All right.
You should be able to take what we did in class and be able to come up with great answers for that. I wanted to give you all some information on our next steps. We know that our quarter ends on Friday. And if you've been doing your
Dang.
work, if quarter 3 ends on Friday, if you've been doing your work, hopefully your grades have improved. Okay.
Mhm.
What I want you all to do is you also should have completed 2 things for me for class today. You should have done your vocabulary definitions as we were writing them down, and you should have done or completed the 3-column sheet that we just did. Your job is to screenshot those. Your job is to screenshot those and to send them to my DM for credit for class today.
Okay.
And you should also complete your warm-up and exit.
Dang.
Okay.
How many hearts? Dang,
All
mama.
right. All right. I have to look at my grades to see who's on the leaderboard. I
I
want to
think I'm
thank
on the
everybody
leaderboard.
who participated today. Real quickly, let me show you this. For those who had questions, you should be able to answer these 2 questions on your own. Okay. And then the next time that I see you, we want to do a little simulation activity so you get a better understanding of what's happening. Okay. If there are no
Okay.
further questions, I love you too. I love y'all too. I'm glad you all are participating and joining in. If there are no other questions, please be sure you get your work done. And I'll see you guys later.
All right. See you later, Miss Tate.
All right. Bye-bye.
All right.